Today's lecture is about graphs. Before we start giving the lecture, we would like to introduce graphs by the following problem. This problem is known as the Seven Bridges of Königsberg. Königsberg is a small town. Its name now has changed. Now it is part of Russian Republic. The town is divided by a river into 4 regions. And people at that time usually take tour to go around the town by using bridges. See, there are bridges connecting these regions. People at that time were wondering, was it possible, this is the problem, was it possible to start at some location in the town, travel across all the bridges without crossing any bridge twice? So they could use the bridge only once, they cannot cross it twice, and return back to the starting point. So people at that town were wondering whether that tour exists or not. A person called Leonhard Euler has solved this problem by converting the problem into a model which is now called a graph. So he represented the regions by circles or nodes, and he represented the bridges by lines connecting these circles. So between this region, which is the blue region, with the green region, there are 2 bridges. So this is why there are 2 lines between the blue region, the blue circle, and the green circle. Also between the orange region and the green region, there is 1 bridge, so it is connected by a line. Now between the red region and the green region, there are 2 bridges, so this is why there are 2 lines connecting these circles. Between orange and red, there is 1 bridge, and this is why it's connected by a line between these 2 circles. And then he tried to find a solution from the graph. And then he claimed that such tour does not exist. His justification was as follows. He said that if a person would like to come to a region and then would like to go to a region, then it needs 2 bridges. So if a person goes out from a bridge, then he or she should return back by another bridge. And if that person also goes out by another bridge, should also come back with a different bridge. So he claimed that any region should be connected by even bridges. Otherwise, the tour does not exist. So here we have 3 bridges, here we have 3, here we have 5. So this is why this tour does not exist. And later we will study Euler cycles, which is called the cycle. And then we will show you how to determine if a graph has Euler cycle or not. So what is a graph? A graph simply is a model that is used to solve certain problems. So the problem is converted into graph, and then try to solve the problem according to the graph properties and the theorems to find a solution to that problems. Graphs are not only used in computer science. They are used in many fields, like for example in science, in business, or engineering. So mathematically, what is the definition for a graph? A graph, in fact, is a set which consists of another 2 sets. If I go back now to the picture that we have drawn for the bridges of Königsberg, notice now here we have these dots or circles, we will give them names, and also for these lines we will give them names. The circles, we will call them vertices, and 1 is vertex, and more than 1 vertex vertices, and we will call the lines edges. And some of the edges in some of the graphs, they have arrows, so they are called arcs. So a graph G, and now this is the label that you are going to use mathematically for a graph G, consists of 2 sets. V will be the set of vertices, which are the circles. In data structures, when the graph is converted into a program, in a programming as a structure, then these vertices are called nodes. So it will consist of set of vertices and set of edges, which are the lines or the arcs, such that Each edge that belongs to E is associated with an ordered pair of vertices. When we say an order, it means if we say that we have an edge between vertex A and B, is the same when we say that there is an edge between vertex B and A. So order is not important. So there are two types of graphs. One is undirected, so the edges don't have arrows, and another one we have directed ones with arrows. Both we will for both types we will have examples later. So this is how we represent the graphs mathematically. We use G, the name of the graph, equal an ordered pair, V and E. V will be the set of vertices and E will be set of edges. Let us go over some basic definitions of graphs. So V as defined as set of vertices, E is defined as set of edges. So now what is a loop? A loop is in fact an edge. So it connects two vertices, but in fact it connects one vertex. So if I want to look at a loop, if this is a vertex, then we have an edge that connects this vertex to itself. So it's called a loop. So if this is a vertex, then if we have an edge that connects to itself, then we say that this is a loop. Parallel edges. They are two distinct, which means different edges with the same set of end points. These end points are vertices. We can draw it as follows. Suppose we have this first vertex, and suppose this is another vertex. If we connect them by an edge, and then we have another edge connecting these two vertices, then we say that these two are parallel, okay? Because they share the same endpoints. Now adjacent vertices. When we say adjacent, it means next to each other. When we say two vertices are adjacent, simply if there is an edge between them. Here is an example. If this is a vertex and this is another vertex, if there is an edge between them, then we say that these two vertices are adjacent. It means next to each other. Now if I have another vertex here and another vertex here, and suppose that these are the edges. Now this vertex and this vertex are not adjacent because they don't have a shared edge between them. If they are connected directly, then they are adjacent. Now these two are adjacent, these two are adjacent, and these two are also adjacent. Now incident edges. Now here we are talking about vertices, now here we are talking about edges. So when we say edges are incident, imagine the following situation. We have 1, 2, 3, and 4 vertices. If this vertex has an edge between these two vertices, and here we have an edge between these two vertices, and here we have edge between these two vertices. Here we are counting the edges connecting this vertex. So here we say that this vertex has 3 incident edges. So when we say incident, it means it is the edge that is connecting other vertex. So this is an incident edge, this is an incident edge, and this is incident edge. So how many incident edges we have for this? We have 1. But if I make this edge available between these two vertices, then now this vertex has 2 incident edges. Now empty graph. Empty graph is because we said that the graph is a set. Sometimes we don't have any edge and we don't have any vertex, so we say that the graph is empty. Now simple graph, which we will define it also later as a special graph. Simple graph is a graph that has neither loops nor parallel edges. And remember, we have defined loops up and we have defined parallel edges, and sometimes called multiple edges. So parallel edges has another name, which is multiple. Multiple, it means more than one. More than one. So if it does not have a loop, and if it does not have parallel edges, then we call it simple. And we will have examples for this in a moment. Now, weighted graph. It is a graph, but on the edges, they put numbers. For some applications or problems to be solved, between the vertices, there is a number that should be written on the edge. As an example, suppose now these vertices represents areas and they are connected by roads. So these are roads. So here the edges are the roads and the vertices are, let's say, the cities. So now if I want to study how much time does it take from one city to another one, then I need to put a number between any two cities represents the time. So here maybe I can put here, maybe this will take 5 minutes to go from this city to this city. Here it takes maybe 2 minutes. Here it takes 7 minutes. Here it takes 1 minute. And here it takes 10 minutes to go between these two cities. So this graph is called weighted graph because it has numbers on the edges. Now multigraph. When we say that we have a multigraph, it is a graph with multiple edges. So multiple edges, it means parallel. So any graph that has parallel edges, regardless if it has a loops or does not have loops, as long as it has parallel edges, then it is called multigraph. Now pseudograph. Now this word pseudo reminds you about pseudocode in programming. Pseudo, it means not real. So pseudograph is a graph with loops and multiple edges, but it doesn't mean that it must have loops and multiple edges. No, if a graph does not have loops and does not have multiple edges, it is still pseudograph. Here what we want to say that it is allowed for this graph to have loops and multiple edges. Now regular graph. A regular graph is a graph that has every vertex of the same degree. Now the word degree here is a concept, and in fact it is the number of incident edges is the degree. Later we will define what is a degree. Here is an example. So for example, suppose we have this graph. Now how many incident edges we have here? We have 2. How many incident edges? We have 2. And here we have 2 and we have 2. So this graph is called regular, and it is in fact called irregular, 2 regular. Why 2 regular? Because every vertex has incident edges equal to 2. Now if you draw an edge between these two, now this one has 3 incident edges, so this is not regular graph. This is a typical example on a graph. If this is a graph, and by the way, these are not 3 different graphs because it is drawn as 3 components, but in fact it is one graph. It consists of set of vertices and set of edges. So the vertices, these are the vertices, and the edges are these that are connecting the vertices. As we said that a graph was a set consists of 2 sets. Set of vertices, and these are the labels of the vertices, V1, V2, V3, V3, V4, etc. And these are the set of edges. Also we have labeled, this is E1 between V1 and V2. This is E5 between V5 and V6, E5. And this is E6, which is a loop, its endpoints as V6. Now for adjacent vertices, V1 and V3, this is V1 and V3. They are adjacent because there is an edge between them. Now E1, E2, E3 are incident on V2. See V2? So E2, E3, E1, E3, E2 are incident edges to V2. Now E7 and E6, they are loops, and V4 is an isolated vertex.